Hi everyone. Um, Today we're going to look at the Tower of Hanoi. So for this game, we can look at the combinatorics behind it to see like a pattern that we can find to find the minimum the minimum number of moves that you can move these three blocks or however many discs into the middle disc from the left. And so let's just test it out. So what if we move this block like here, this one here, this one here. And then now we need to get this middle one there. So we need to make sure that these two blocks or this are on the right so that we can move it. The biggest block to the middle. So let's do that. So as you can see, that was not the most efficient way because they said the middle moves can be seven. And you might have seen like some blocks being moved back and forth in the same sequence. So we want to avoid that and get the minimum possible moves. So one way we can do that is that we make sure that we get these two blocks onto the right. And so if we get it to the right, then we can move to the bottom one and we're set. So we do one, two, three, four, five, six, seven. And there you go. You beat the game with a minimum number of moves. And if we only had two blocks, the number of minimum moves that will take would be one, two, three. And for one, it's just one. So that's for that. So let's go back to the whiteboard. And this applies for more discs. You will want to move these three stacks to the right, and then the bottom one to the middle, and then you move the three stacks back to the middle. And so let's go to the whiteboard. Um, okay. And so uh, we see that in the Tower of Hanoi, we had these three stacks, and say we had like one, two, three discs. So if we look at the sequence-wise breakdown of this game, we can see that our goal is to move these two blocks to here, the last one to here, and then move these back. So you may see like a pattern here, right? You will basically want to do the previous sequence, which we can call h of n minus one, if we're using h of n as the current one. And h of n is the number of middle moves that I'll take for n number of this. Um, then it's gonna take this many moves to get the top n minus one this to the right stack, and then one move to take that last stack to the middle after you moved all the other stack all the other disks, and then you'll take another h of n minus one to move the two blocks back to the or like the n minus one blocks to the middle. And so we can rewrite that as this. And so if we know this recurrence that h of n holds as 2h minus 1 plus 1, and we want to find the explicit formula for this, we can use the characteristic root method, as we talked about in a different video. This one is a non-homogeneous equation or problem because there's a 1 right here, and that makes it not non-homogeneous. And so how do we solve this? We first solve the homogeneous part, which is this part, which we could do using the lambda method. We we replace lambda with h with lambda, and then we have lambda to power n minus 2 lambda n minus 1 equals 0 after moving the right h n minus 1 to the left. And so we can rewrite this as lambda n minus 1 times lambda minus 2, 0. Otherwise, we have a lambda solution as lambda equals 2. And so we can rewrite the homogeneous part as h of n equals to 2 to the power of n times some constant a. And next what we do is we take the non-homogeneous part and we use one of our requirements that we will transfer this into the equation we want, which we can test using just a constant. If the constant doesn't work, then we can use a linear uh, a guess. Basically, we would have like a form of bx plus c. But in this case, let's test the b first because it looks like b will work the best here. So we have this form for our equation for an expressive formula for the sequence as our solution. And so now we can just solve for a and b and see if it works out. And so note that we already found for the first sequence, it takes one move to take the one block into the middle slot. And so we know that h1 equals to 1. And then we can say h2 is equal to, well, these two blocks move one there, one middle, and one back. So h2 equals 3. And that's all we need. And so we can have 1 equals to a to the power of 1 plus b. And then we also have 3 equals to a to the power of 2 plus b. Now we just solve this equation. We subtract both sides, like subtract it from bottom up. And we get 2 equals to 3a. Oh, I'm sorry, 2. So then we know that a is equal to 1. Let's plug it back into the first equation, and we get 1 equals to uh, 2 plus b, which is saying that b is equal to -1. And so we solved our recurrence for this game called Tower of Hanoi. And so we have h of n equals to 2 to the power of n minus 1. That's our final solution. There's a lot of games like these that we could use combinatorics to decipher like the pattern behind it. And in this case, it's very useful because we can use this to like win against our opponents every single time, or at least draw. Um, and so yeah, I encourage you to like play around with this game. You can search up Tower of Hanoi, and then click on the first link, like say game, and the website is called Math is Fun. Um, so yeah, I hope you enjoyed this video. And have a nice day.